Modems, those things we used to use to go on the internet by screeching down a telephone line at another computer whose modem would convert that screeching to data and vice versa. Here you see a selection of modems out of a big box of modems that a couple of people on a Vintage Computing Facebook group generously donated me for my own experimentation. Said experimentation is what I'll be demonstrating in today's video. All ISA and PCI modems, except for this one guy, which is too bad because it's the biggest, fanciest of all the modems. I think this was meant as a dedicated fax board or something, I don't know. But this is microchannel. This is a microchannel card. So this would have been meant for use in an IBM personal system 2 or another computer that's based on microchannel architecture. So it's too bad I don't own an IBM PS2 or another MCA based computer, so I have no use for this. So if anybody wants a modem for a microchannel computer, get in touch with me. But then here, for example, here's an 8-bit ISA modem. This one's from 1996. Here's a US Robotics 16-bit ISA modem from 1998. This one's a bit funky looking with the shape of the PCB. You've got the transformer. This one's got a full range speaker instead of a piezo beeper, which is kind of unique, based on an Analog Devices chipset. And near the end of when modems were included with computers, around the mid-2000s, what you usually got was something like this. The very tightly integrated, you just got one tiny chip on there, maybe a couple of other support chips. The transformer's gone. It's been replaced with metal oxide varistors to protect the circuitry from the sometimes high voltages of the telephone line, such as when it's ringing. And you've got no speaker or piezo beeper at all, so no way of telling audibly what the modem is doing. And yeah, all these I got were expansion cards. I didn't get any serial modems. I'd love to have a serial modem someday. If anybody has a serial modem that they're not using that they'd like to donate to the channel, get in touch with me. Now, modems are among my favorite things because they combine two of my biggest interests, telephony and vintage computing. But there's obviously not a whole lot you can do with a modem these days. Well, something neat you can do if you do have a telephone line, which I do, or at least if you have access to one of those VoIP boxes that connects to a free Google Voice phone number, there are some dial-up BBSes still in existence. So I have a modem installed in the IBM portable PC, a 33.6K modem, which is way too friggin' fast for a computer of this caliber, but it's the slowest modem I have. All the modems in that box that I showed, they're all 33.6 or 56K modems, but I've got it connected to my telephone line over there. And I will dial one of these dial-up BBSes that still exists, and in fact, this is a great one because it's toll-free. It's called Heights BBS, and the number is 1-800-258-4660. So if you have a dial-up modem in your computer and a telephone line, this is a really neat way to play with your modem. So we'll dial it up here. And you'll be able to make the modem you'll be able to hear the modem handshake. And we're on. Now the modem handshake you heard after the BBS answered the call didn't sound like what probably most of you, especially if you're around my age, remember a dial-up handshake sounding like, and that's because although this has a 33.6K modem, which has a stereotypical sounding modem handshake, I've forced the modem to operate at 2400 baud because when I tried to dial into this BBS with the modem running at its full speed, it would not complete the handshake, and eventually the line would just drop. So maybe it's just a weirdness with the modem or with my phone line, I don't know. But we're on Heights BBS here, and today is... Oh! I waited too long flapping my gums, and it... There, it hung up the line. No carrier. Let's try that again. Alright, now it says connect 57600. Normally it would say the actual, speed that you're connected at, but it says 57600 because that's the speed at which the modem communicates with the computer. So that's the communication speed between the computer and the modem, not between the modem and the remote modem that it's calling. Here we go. At a 2400 baud, or this might actually be 1200 baud, I'm not actually sure. That particular handshake sound is applicable to both the 1200 and 2400 baud modems. Alright, now I don't remember my credentials. I do have an account on here, but it might be the Maritime Girl. And my password might be this. And it dropped the line. Okay, so something was going on there, or maybe it just kicked me off because I didn't know my password. But yeah, there you go, a demonstration of dialing into a BBS from a modem in 2019. Pretty darn cool. But let's say you don't have a phone line or one of those fancy voice over IP boxes. What can you do with a modem in your computer? Are they just totally useless? Nothing you can do with them? Well, the answer is no. You can actually make use of a modem in a computer without having access to the outside world at all. And I'm going to show that in today's video. There's actually a way, and it's pretty easy to do, that you can connect two computers, just two computers sitting on your desk. You can make a direct connection between them through their dial-up modems without having to have access to a telephone line. And you can use this to transfer data between them, like transfer files between the computers without having to use floppy disks or whatever. That's especially useful if you have a computer as old as this. Now I stole the 3.5-inch floppy drive out of the Epson Apex Plus because I absolutely hate working with 5.25-inch floppy disks. But if I still had the 5.25-inch floppy drive in here, then I could use the modem in this computer to dial another computer with a file that I wanted to transfer to this computer, and use that direct modem connection to transfer that file to this computer. So there's actually a bit of usefulness to it, or if you just want to play around with modems for the sake of doing it, like I've been doing a lot, this is a way you can do that. Now, in some cases, a few cases, you can literally just connect a telephone line between the two computers, and they will communicate with each other. But in most cases, this won't work. And the reason it won't work is because modems look for the proper voltages on the telephone line to detect that there is a connection to the telephone line. A standard POTS telephone line in standby usually has about 48 volts DC across it. When something is off hook and, transferring voice or data across the line, the voltage usually drops to around between 3 and 9 volts DC. And when the phone rings, that voltage is 90 volts AC, and it's a very high voltage because that's what they needed back in the days to ring the mechanical bell ringers of the old Western Electric 500 and 2500 phones and the many, many other phones that had mechanical bell ringers. So in most cases, a computer modem looks for a standby voltage on the line to know that it's connected to a telephone line. If there's no voltage, or if there's too low of a voltage, it's going to assume that it's not plugged into anything, and when you try and call another computer from that computer, it's just going to say that there's no carrier. That's that no carrier message you saw when I was trying to connect to that BBS. there's nothing there to connect to. That standby voltage isn't there. Well, you can simulate that standby voltage simply by connecting a 9-volt battery, or any battery of sufficient voltage, at least 9 volts, through a 500 ohm or thereabouts resistor. It's really loose. It doesn't matter too terribly much. Basically connect the battery through the resistor directly across the telephone line. So this is your telephone line going between your two devices. They could be computers with modems, or they could be phones, whatever. If you've ever heard of the thing where you can make two old telephones into an intercom by connecting a battery and a resistor across them, well, this is the exact same thing. It's all about creating that standby voltage so that there's some electrical medium through which your voice, or in this case modem data, can travel. You need electricity to be able to do that, and that's what this 9-volt battery through this resistor is providing. It's probably pretty obvious you need the resistor there. If you don't have the resistor there, there's just going to be a dead short across the line. In standby, the line is open circuit, but as soon as something goes off hook, it's pretty much a dead short or a nearly dead short. But once something goes off hook, there's a load on the line, and you don't want a battery just being short-circuited across the line and across whatever's off hook. And that's pretty much it. In every case I've tried so far, this works perfectly to allow to satisfy a modem so that it'll go off hook, dial another computer connected to the other end of the line, and you can start playing with modems and dial up data transfer and whatever you want locally without having an actual connection to a telephone system. Now there's one caveat to that, and that's there's no facilities for ringing something on the line, because there's nothing here to generate the 90 volts AC for ringing. So you can't use one computer to ring the other computer and have it automatically answered. You have to take the answering computer off hook manually. So you establish a connection with one computer and then manually answer the call with the other computer just by bringing it off hook. You could absolutely add a device here to add the ringing voltage. You would just tap the output across the line. You would need some way to automatically activate the ringing voltage when you wanted to, or at least do it by hand when you wanted to. And you'd need some way to protect this part of the circuit from the 90 volts AC. But it could be done if you really wanted to. Oh, and polarity doesn't matter. It doesn't matter whether, I drew this in a certain polarity. I really shouldn't have. But just to show that it's a DC source. That's what matters, is that it's a DC source. But polarity doesn't matter. It doesn't matter which terminals on tip and which terminals on ring. So I've assembled this circuit right here using this little doohickey. It's just a standard telephone junction box, and it's got this black wire coming out of it which connects to one computer, and then it's got this jack here which you connect a cord to plug into the other computer. And tapped across the two wires, the tip and ring wires they're called, are these two blue wires, and I've got them plugged into the circuit board, and I've basically got these connected in between my 9-volt battery here and around 500 ohms of resistance. And I've also added this yellow LED here in series with the resistors because the LED will light up when something goes off hook. Current is only drawn once something goes off hook, so I actually don't need a power switch or anything. As long as nothing's off hook, no current will be drawn. You won't drain your battery leaving it connected, but as soon as something goes off hook, current will be drawn and that LED will light up. And it's only a tiny amount of current, so you don't need another supplemental resistor for the LED. The 500 ohms of resistance will be plenty. And yeah, connect to one computer, connect to the other computer, and then you can use terminal emulation programs to establish a connection between them. So I'll show you how to do that next. Now, before I add a second computer to the mix, I'll just show what happens when I have one computer connected and I take it off hook, and you'll be able to see that LED light up. Now, I don't know if it's crucial or not, but it certainly makes things a lot easier if the modems you are trying to connect together are Hayes compatible. I've talked about Hayes compatibility in the video I made of my Wi-Fi 232 device. Hayes made the first intelligent modem. It was called the Smart Modem 300. It was the first all-digital, automatically controlled, intelligent modem, 300 baud. And it established what would become the biggest standard for modem control, and it's called the Hayes command set. It's sometimes also called the AT command set because every command begins with the letters AT, which stands for attention. If you type AT on its own, it just prompts the modem to do a generic response. And it says OK. So AT is just a way to show that the modem is actually functioning. ATA is the command for the modem to answer as if it was answering a call, but you can command the modem to answer at any time. So if I do an ATA, you'll hear it do the beeping sounds that a modem emits to say, hey, I'm a modem, talk to me. And I just press any letter and it hangs up because there was nothing on the other end that was also off the hook. Now that wasn't very loud, but if I do ATL, ATL is the loudness command. So if you ever go into the device manager of your computer and you have a modem installed, and the properties page for that modem has a little volume slider, all that volume slider does is do one of the ATL commands. ATL 0, meaning the speaker's off. ATL 1, which is for the speaker to be on its quietest setting. Or ATL 3, which is the loudest setting. So I'll do the loudest and I'll do ATA again, and actually you'll see when I hit enter, you'll see that LED light up. I thought the speaker was a lot louder in this thing, but I guess it's not. But you heard it do the beep, and now it's doing a beep at a higher pitch because how modems handshake is they assume the fastest speed first, and if nothing responds at the fastest speed, they fall back to slower speeds. So this is the answer tone for a slower speed modem, a 1200 or 2400 baud modem. Likewise, ATD is the dial command. Now, I can type ATD in any combination of numbers, and when I hit enter, it'll go off hook and dial those numbers. And actually it says no dial tone, so I have to turn dial tone detection off. So I'm going to issue an ATX command. X means ignore a no dial tone condition and also ignore a busy condition, so it won't hang up if it hears a busy signal. ATX. Now if I do an ATD, or actually I was going to do, let me try that again, ATD in a bunch of numbers. You might not have been able to hear that, but it did dial that string of numbers. And you can see the LED is lit up right now because it's off hook. Because no connection has been established, I just press any letter on the keyboard and it hangs up. Now, ATD actually has two subcommands, ATDT and ATDP, and those select either tone or pulse dialing. I find in every instance I've ever tried, just putting ATD dials it in tone mode, so maybe that's just a default, but if I do ATDP and a bunch of numbers, you'll be able to not only hear the buzzer clicking on the modem as it does the pulse dialing, but you'll see the LED flicker as well, because that's how pulse dialing works. It goes on hook and off hook very rapidly. Let's observe. You might be able to hear that. So that's your basic control of a modem. You open up a terminal emulation program, point it to the COM port that the modem resides in, and you can use these AT commands to talk to the modem and make it do things. There's some pretty neat things. If you do an ATI3, that commands the modem to puke out its identification. ATI3, press enter. And this modem doesn't have anything terribly interesting. It's got a version number. It says v.34, so it's v.34 compatible. That's the 33.6K modulation. Some newer modems will actually store an entire text string with the manufacturer and model number of the modem. And actually, when you go into the device manager and you look at the hardware information page, Windows is just doing those ATI commands to bring up all the information. ATI3 is the most interesting one, but there's ATI1, which gives some stuff. ATI2, which just gives an OK in this case. And there's some stuff when you're doing ATI4, just random technical data. But yeah, that's basically your control of a Hayes compatible modem. Now let's connect another computer to this computer and establish a connection and have some fun with modems. Alright, so let's add a second computer to the mix. Here I've got the Epson Action Note 4 SLC33 laptop from 1993, and I've now got this connected via its 2400 baud modem that's built in to the IBM Portable PCs modem that I installed through this telephone cord. Electrically, they are essentially connected directly together by the modems, but then I have my 9-volt battery circuit tapped across the line to provide that loop current, that low voltage DC that the modems need to see in order to be satisfied that they are on a valid phone line. So I've got my terminal emulator Banana.com running on both of these machines, and to establish a connection, basically I issue the ATD command on one computer to bring the modem off hook and wait for an answering modem, and then on the other computer I run the ATA command to begin the answering sequence, which the first modem will hear, and then they'll begin the handshake. It doesn't matter which computer does the dialing and which one does the answering. Just do one on one and one on the other. So I'll do an ATD on this, and when I hit enter, the yellow LED will come on. And then I'll do an ATA on this, hit enter. Oops. And they're connected. The IBM says connect 57600 because once again that's the serial communication speed between the modem and the computer, not the speed between the modem and the remote modem. This one does give the actual communication speed between the two modems. It says connect 2400, that's 2400 baud, and then V42. That refers to ITU-T recommendation V.42, which is a compression algorithm. So these computers are now on what could be considered an emulated telephone call. They are connected together, that yellow LED is lit up, and we can now communicate between them. The simplest way of doing that is if I type on the keyboard here, what I'm typing is showing up on the IBM, and vice versa. I type on the IBM and it shows up on this computer. Now let's do something a bit more interesting and transfer a file. Now something I haven't mentioned yet that I should mention is that there is a way to use a cable connection to transfer data between two vintage computers that's way simpler than this modem setup. You can use what's called a null modem cable. It's a serial cable. It connects between the two serial ports of the computers. And it's called a null modem cable because it essentially provides the functionality of a modem connection, but there's no actual modems. Instead of going between two modems connected to serial ports, it's just skipping the modems and going directly between the serial ports, referring of course to early modems which were external and connected to the serial port of the computer before internal expansion card modems started becoming more commonplace. So let's send a file from one computer to the other. I have a 38 kilobyte JPEG image that I'm going to transfer from this to that. So how you do this depends on the terminal emulation, but in a Bananacom, I just got to go into the menu here. I'm going to go into more options, and I'm going to go Z modem upload. There were many different modem file transfer standards. There was X modem, Y modem, Z modem, and then one called Kermit. Bananacom gives you Z modem and Kermit as the choices. Z modem was the fastest and most reliable one, so we're going to choose Z modem upload. And I have to name the file. Well, the file is called flow.jpg because it's a selfie. And so when I hit enter, a nice feature of Z modem is that it'll automatically prompt the other computer, if its terminal emulator also supports Z modem, to automatically begin downloading the file. In earlier modem standards, each party had to manually begin the file transfer process. The receiving party had to manually tell their terminal emulator to begin receiving a file. But I'm just going to hit enter on the IBM, and a file transfer dialog automatically opens up on the Epson. It's got the name of the file. It's got the file size. And we're beginning the transfer at 2400 baud, and that equates currently to about 250 bytes per second. So blistering speed here. And it gives an approximate time about 2 minutes to transfer this 38 kilobyte file over a 2400 baud connection. And there, the file transfer has ended, and I can view the file. And Bananacom has its own file viewing program. It can view text files and JPEG images. And pardon me, I've got a test file that I transferred that has a naughty word in it, so I'm just gonna have to block that out. But I'll open flow.jpg here. And Bananacom doesn't do the best job. It's it's off the screen here. But there you go, a 38 kilobyte JPEG image transferred over a 2400 baud modem connection in a couple of minutes. This was early long distance digital communication stuff we're dabbling with here. So this is really, really cool. Now, something else that's kind of neat that you can do with Hayes compatible modems is you can force them back into command mode after a connection has already been established, and the modem doesn't have to hang up the connection. So you can issue commands to the modem while a connection is already in progress. And how you do that is you do 3 plus signs. You go plus plus plus, and that's the Hayes command to put the modem back into command mode. So I'll go plus plus plus, and it says OK to let me know that we're back in command mode. And I can just go ahead and issue, random commands. There's the ATI3 on this computer. It's got a date there, 6/08/1993, and a revision number there. And one command that you can issue that's kind of neat is you'll notice that when a modem handshakes, it keeps the speaker on so you can hear the handshaking, but then it mutes the speaker after the handshake's been completed and the connection is established. Well, you can unmute the speaker so that you can actually hear the connection, and that's ATM2. ATM2 forces the speaker on all the time. So if I do an ATM2, you'll now hear the hissing sound. That is the data. To put the modem back where the speaker is only on during handshaking, that's ATM1. And if you want to keep the speaker muted all the time, you don't hear the dialing, you don't hear the handshake or anything, that's ATM 0. Oh, to put the modem back into the normal mode, while it's in command mode, you do an ATO. And now it's back in the normal mode. I type keys and they show up on the remote computer. I'll do the same thing to this one, do a plus plus plus. And it's in the command mode. I'll do an ATM2. And this one's a bit louder. I'll hang up the connection here. And we'll just do that again. We'll do a we'll just dial. We'll establish a connection again. And there, the connection's been established. Do a plus plus plus. And ATM1. And there you go. Well, that is a demonstration of some fun things you can do with the dial-up modem in your vintage computers. You know, for the longest time, you know, for as long as I've been dabbling in vintage computing, I always figured that the dial-up modem was something that was always going to be an appendix in a computer, just something totally useless that serves no purpose that you can play with today, unless you're one of those people that has a telephone line, which most of us don't anymore. But as it turns out, with a really simple electrical circuit that you can just set up on a breadboard, you can make two modems talk to each other with no connection to a telephone line at all. And this could actually come in handy if you have vintage computers that you want to transfer data between, but you don't want to do it through floppy disks, and perhaps you don't have a null modem cable. This is a way to make that happen. And it's really fun. It's really fun just to establish a connection and listen to the handshake and just, you know, observe it working and stuff like that. And I'm really glad I discovered this trick. I read it on a website online, the little trick with the 9-volt battery. And yeah, it's totally awesome. Something else, in fact, that you can do is establish a connection between a computer and a fax machine and send a fax from one to the other. And I'll demonstrate that in the video where I review the Brother Fax 575 fax machine that I recently got in a thrift store haul. When I make the video review of that thing, I'll actually make a connection to a computer's modem using this trick, and I'll show how you can send and receive a fax between your computer and your fax machine. As a matter of fact, you'll basically be able to use your fax machine as a printer, a really crude printer, by making a local connection between it and your computer. So that's all for this video. I hope some of you found this really interesting. I've certainly been having a lot of fun with it. I will end this video by connecting the IBM portable PC to a newer computer that has a 56K modem, so that you can hear the later handshake sounds that started with the 28.8K modems, since that's what a lot of us think of when we think of a dial-up connection establishing. Since this computer has a 33.6K modem in it, it'll make that handshake sound when it's connecting to another 28.8K or newer modem. So let me set that up and then I'll show you that.